Hey everyone, it's Mythic here. This is going to be a recap of what we went over in the last meeting. This one's going to be a little different as I'm going to incorporate a little bit different things that wasn't necessarily shown in that meeting. But we're going to dive deep into the Unity input system in today's episode. So let's go ahead and get into it. I posted a video of the whereabouts of getting Unity set up, and this is the same project that was created in that setup. So you can go ahead and find that tutorial down below. It's like a short 5-8 minute tutorial. Alright, so now that we have Unity open here, first thing we want to do is go to your window, package manager, and your package manager should look like this. You want to click this button here and go to Unity registry. From there, search for the input system and click install. It may ask you to restart the editor, which is fine. Just go ahead and click restart. It should only take about a minute to restart at that point. Alright, so now that the input system is successfully installed in Unity, we can take advantage of it by right-clicking, create, scroll down, and you'll notice that we have something called a input action. Alright, so I'm going to go into the mapping, and I'm going to call it our main input mapping, or I guess main input controls, would probably be a better name. And on this mapping, we're going to give it a main input mapping, like so. We're going to add an action. We're going to it gives us the default one. We'll just go ahead and turn that from a button to a value, giving it a vector 2. The reason we're going vector 2 here is because we want, to go A and D and W and S, meaning we want two different values, from -1 to +1 on the X value, and then to go from -1 to +1 on that Y value. The reason we want two values here for vector 2 is because we want a X and a Y. The reason we want this is, for instance, if we're pressing A and D, right, we want to go left and right, and that's going to give us a value between -1 and +1. And we also want to go up and down, which is as well going to give us a value between -1 and +1. So we can take this into account with this action here. So now if we left click on this, binding, you'll see it says add up, down, left, right composite, which will just give it that. We can delete the original binding. I'm just going to name this new action to be called our movement action. So it's kind of like when we're moving, right? Because we have up, down, left, right. This path here, we'll set that to W keyboard. We have a down key, that'll be like our S keyboard. Same with left and right, so that'll be our left keyboard. Left key, and this right key will be our right key. Again, you can have multiple bindings here, so you just duplicate this guy, and instead of setting this guy here, what you would do is go ahead and on your gamepad you can manually select it here, or what you can do is manually click your icon on your gamepad. Alright, so now that you have all this done, click Save Asset, close this, and generate our C# class, and click Apply. So let's right click here, create a new C# class. We'll call this our input test. Okay, like so. And we're just going to open it up. Make sure you don't have any spaces when you're typing it, just because Unity can be a little weird when creating your C# classes with spacing. So here we are in our class right here. We can actually go ahead and remove start and update. We won't be using that. So there's two different methods. The first method is really simple. We'll go ahead and make a public void. We'll call it used, or I guess we'll call it move input press. And we'll give it a parameter of input action dot callback context. I'll name it context. You can name it whatever. I just like to do that for name simplicity. And right here, what we'll do is we'll simply just say debug.log. We'll say press or something like that. Private static integer, and we'll call it pressed amount or pressed times equal to 0. And every time we press this, we'll just simply up it by 1. This just says plus plus just means 1. 1 plus the original value, and we'll go ahead and leave that as it is. So in Unity, we can create a new empty object, and we'll call this our input handler. And in here, we're going to drag in our input test, as well as using a player input component that is added with the input system. Now this wasn't shown in the class mainly because I don't think this is a necessary or a great way to do your code, mainly because you're reliant now on another component. But of course you're allowed to use it. So that's what I'm showing you here. This needs a reference to a mapping, and that's one of the downsides is it only can contain one action mapping at a time. Like the whole mapping, obviously you can change the maps in here, but one actual object type of this. Another thing is it only can call certain things, so you can't like enable or disable in here. The only time you would be able to is if you disable this object, that would disable everything, unless you're manually setting it. So that's why I just might as well have my own script to do it. So the first thing we're going to do is we're going to change this from send message to invoke a Unity event. Essentially what that does is it's going to give us a drop down for our main input mapping, and we can click plus here, drag our input mapping on it as an object reference. So now we'll go to player our input test, and under dynamic callback contest we have move input pressed. And one last thing is I also want to display this press times, so we use string interpolation here, do brackets and press time like so. Okay, so under our console window now, and we'll click play, you should see our input already working. So we'll click left, you'll see it presses it 3 times, left, up, and you'll see at the moment I let go, press the 9. And the reason it's calling this is because how Unity phases work. So it's got on started, on performed, and on canceled. Essentially what that means is you have 3 different states. A way to easily check this is instead of doing this press time now that we kind of showed that, we can see here that if we instead do context.phase, and I'm going to give this guy a color so it stands out more. We can just use some simple HTML in here. So we'll display that phase. I'll go and click play. And now in our console, if we left click, you'll see started, perform, canceled. And we do it again. And actually, if I uncollapse this, might be a little better. So the moment I let go, that's when cancel is called. We can use this to our advantage if you like. You can simply do something like, let's say we only want to show this if our context is not, if we'll say if context.phase is not a input phase dot, let's say performed, we can return. So simply it will leave the function, and that's thus meaning it will only call this code underneath if it is in that perform stage. So if we go in here again, you should see that it works. See, only on performed, which is what we want. You see that count's going up. Now, like I said, there's different ways to doing it, but my personal opinion, I think you shouldn't use the player input component. Instead, I like to have everything in the same class, so you're not referencing or having to do anything like that. So the first thing we want to do is reference our name of that player main input name, reference the action, so main input mapping, then grabbing our map, then grab our action to grab, obviously, our bindings and our values associated with them. So what we want to do is we want to simply grab it. So we can say a private main inputs controls, and we'll call it our inputs controls. And here we'll have a private void awake. This gets called when the object is either spawned in the scene or is instantiated. So start only gets called when the scene starts. I like to do on awake because say you want to reinstantiate the player or this object for whatever reason, every time that happens this will get called. So we'll say input controls equals a new main input controls. This will create the object. Then what we'll do is we'll simply say our input controls dot main mapping dot movement action dot enable. This will go enable that action. I like to do them separately, but you can also enable a entire mapping as well. From here, we want to go ahead and say input controls dot main mapping dot movement action. dot performed plus equals move input pressed. What this does is it adds, so this performing takes in a delegate. Essentially, a delegate is is a variable that stores the location, the return address, or I guess the address to call the function, right? So what it does is it will able to call these functions when it's called upon, like invoked. So for instance, when the perform thing is invoked, it will invoke this function. So what this will do now, and if we actually just go ahead and save this, um, you'll see now we don't need that extra component, no referencing needed. We go to our console, and you'll see we can still interact, and that's great. We also don't need this if statement now because this is only being called on performed. Okay, that's great. So why don't we do some cool stuff here? So why don't we go ahead here and let's go ahead when performing we do something, and when disabling we'll do something. So I'm just going to copy and paste this, and we'll say when canceled we'll do this. So we'll simply say, okay, if our if our context dot phase is our input phase dot performed, we'll do something. Else we'll do something else, meaning it's going to be on cancel because we only have two right here. So why don't we create a primitive? So I'm going to say var obj equals GameObject dot create primitive. This is going to need a primitive type, so primitive type dot, let's do a sphere. And let's go ahead and set the transform. So we're going to say our obj.transform.position equals our transform.position, so we're sending it to this object's position, plus a new vector 3, and we'll assign this here in a second, but I kind of want to explain how I'm getting these values. So if we look at our camera, and I'm going to right click reset transform, it's currently here. So we get a game view, and we give this guy like an identifier. It's actually here, so if we get an identifier like that. If we move this guy to the left on the X or on the right, you can kind of see. So I'm going to subtract the Z, so it's a little closer, like so. So negative Z. And let's see, so we're going to spawn a primitive here. Let's go negative 3 there. So what we can essentially do is leave the values like it is here, but then we can add a value. So let's create a sphere on the left, and a cube on the right. So we can simply say negative 3, and then 0 and 0. This will go ahead and do that. And then what we want to do is we want to reference the material. So we'll say obj dot get component mesh renderer dot material equals, and we're going to create this value now. So we're going to go to our assets, right click, folder, and let's call it resources. Again, it needs to be named exactly like this, otherwise you're going to get an error. We're going to go to create material, and we'll go ahead and call this guy our primitive material, like so. And we're going to set it equal to our resources dot load. We're going to paste in the name of it. Don't put the dot mat at the end, just because it will already know once we specify what the type is. So we'll say type of material. We'll cast it as a material like so. What this will do is set the material to this type. And actually what we're going to do is, now I'm thinking about it, let's do this on awake. So sorry about that. Let's do it on awake. Because we don't want to create it every time. So we'll do this. Like so. And then I'm going to do the same here. And then this time we'll do, like, let's say a cube at positive 3. And now we can grab that material. Now this material, if you, for instance, were to spawn in, let's say, a primitive cube in the scene, and let me just reset the transform, you'll notice here that if we apply this material, The material itself, if we go to this three dots, debug, has a under save properties color, it has a parameter of base color, and we can actually adjust this value. Now this value here has the name of base color, so we can actually change this value here. So on phase, let's go ahead and cache in these variables. So change the primitive types. So we're going to need to cache these. So let's go ahead and create a private mesh renderer called our primitive types, type 1, and we'll do the same thing, type 2, and instead we'll set primitive type 1 equals our obj. So what we'll do is we'll set our primitive type 1 equal to our obj.getComponent mesh renderer, like so. And we can do the same thing for primitive 2. So primitive 2 equals obj.getComponent mesh renderer. Alright, so this will go ahead and grab that component. Oop. And again, this obj needs to be called up here. Now we can, instead of doing this, we can say primitive type 1, and this guy can be primitive type 2. Okay. Alright, so now we can simply say primitive type 1 dot material dot set color. Again, it's underscore base color to a new color. Let's go ahead and set to 1 on red, 0 on green, 0 on blue, and 1 on the alpha value. And then we wanted to copy and paste this for our primitive 2 right here. Okay. So now we can just copy these two, paste it down here, and we want to set it now to be 1 on all of these. So that will set it to white. When you have red, green, and blue together, obviously that makes white. So we'll go ahead and click get out of that, go back into normal mode, delete the cube, and we'll go back to our input handler, and if we go into game view, we should see the cube being created. I'm going to uncheck gizmos. So now when I hold down my input, it is red. When I let go, it is white. Alright, cool. So that's what you wanted. Alright, so now that we got that, why don't we try rotating the object? So what we can do is actually do this on something like update, or we can do it on, let's say, awake. But a better method to do, so I'm going to show you two different ways to do it. So first of all, why don't we create a private void update, which is a unity function given. And what we'll simply do is say if our, let's say, our input controls, I just realized I spelled controls with two L's. That looks really stupid. I apologize there. Okay, if our input controls dot mapping dot movement action dot read value as a vector2, right, because that's what we had, and we'll simply say if our x value is greater than 0.1 float, that means we're pressing our x, so our D key. We'll simply go ahead and say our primitive type 1 dot transform dot local Euler angles equals, and actually we'll say dot rotation equals quaternion dot Euler. So this is going to take in and turn it into Euler space, so like Euler angles. And we're going to give it a new parameter. So we're going to say our primitive type 1 dot transform dot local Euler angles. And just to make it look cleaner, I'm going to click enter here, plus a new vector 3. And I want it to rotate on the Y. So if I go create a 3D object, a cube, I want it, and I'm going to reset this transform here. Go to game view. I want it to rotate on this Y value. So that way it's rotating dependent. So we're simply going to rotate on the Y by a certain speed. So we can say a serialized field given a range for that attribute between, let's say, 0 and let's say like 30. and this will be a private float value of speed, rotation speed. Set that to like 1 by default. And we're going to put in 0 rotation speed multiplied by 10, just so it's a little bit faster, multiplied by time.delta time, and then 0. The reason we're doing time.delta time here is so that way it is same speed between all frames. There we go. We'll go ahead and copy this and paste it for our primitive type 2. Although we won't really see it because it's a sphere, it is what it is. And make sure you're changing this to 2 as well. We'll go ahead and save this. And back in our scene, we'll go ahead and click play. And now when I hold it, you'll see it rotates only when I'm holding it. I'm going to change the speed a little bit faster. So let's do like around 15. You see it is rotating. You can actually see it happening on the sphere as well if you go to the sphere because it has a collider on it. You'll see that sphere right there. So in game view, if I rotate, you'll see you can actually see the collider is rotating. There you go. But again, this is happening on every frame and it's checking this value every frame. A better way is to do a static method to check the time that we're pressing something. So let's go ahead and do that. My way is involving a static method, so that way it can be reused. So we're going to right click, create a C# class called our static. So I'm going to say m underscore for mythic static inputs actions, like so. And this does all static, functions that you want in here to be called, or enumerators, or anything really that's static. Alrighty, so we're going to delete our start and update methods. We're also going to remove mono because it doesn't need a base class and turn this into a static class. We don't need to have the systems as we're not using lists. And we're going to be using the Unity engine dot input system. All right, so first of all, we want some type of delegate to be called. So I'll just make one. It's going to be a public delegate void because it's going to have no action type. And then I'm going to call it our input action void delegate. Or actually, we'll call it input action delegate. Then we're going to make another delegate, so public delegate void action delegate, like so. And this guy is actually going to not be void. Instead, let's give it that callback function. So we'll say input action dot callback context. So this will always give us that so we can cast to that type. So simply what we're going to do is we're going to have a public static i.e. numerator. Oh, sorry, we don't need collections. That's generic. And this enumerator is going to be called press input callback response vector to value. Now you could improve upon this by saying using templates, but I'm just not going to in this example. It's going to take an input action dot callback context. I'll call it context. It's also going to need a action which is going to take in a coroutine. I'll call this our callback co. An action as a float. This simply could be like our time pressed. And a input callback, or I guess our input action delegate. So this is simply what's going to be called our task when finished. I'm going to put this on the next line. And then we're also going to have a input action I guess I'm gonna say input action delegate callback context. And this guy is going to be our input action delegate callback context. Actually, I'm going to rename that. I think this would be probably a better name, like so. And we'll call this every frame. So tasks to call every task every frame. So simply this is going to be what's called every frame and so on. So what we're going to simply do is have a float time equal to 0. We'll have a while loop and we'll simply put in our context dot read value. We'll pass in a vector2 and we'll say whatever vector2 we want. So again, this is going to need some type of parameter to check. So we're also going to pass in one more parameter here. So I'm going to add one right here called a vector2 called check or continue condition, like so. So while our context.read value and we'll say .x is greater than continue.condition, or our context.read value, and we'll cast to a vector2 dot y is greater than our continue condition. And again, this will take the y value, and this one will take the x. So simply, if it's greater than, and we'll say equal to, just to make sure that if we're not pressing at all, it should be fine. Okay. What that will do is simply call this stuff during. So while this is happening, we're going to simply say time plus equals time dot delta time. So that way we, not that, time dot unscaled delta time. So this will go ahead and grab unity seconds in real world time. And it's not even going to be dependent because it's unscaled delta time. So it's not dependent on the unity time scale. We'll go ahead and yield return null here. And let's also go ahead and add an if statement. So we'll say if task every frame is not null, we'll simply say task every frame dot invoke. So we'll go ahead and invoke it if it's not null. Then when we're finished, we'll say time, and we'll go ahead and cast it, passing in, our actual, we'll say time pressed. We'll pass in time here, and then we'll simply say if our callback co is not null, we'll simply call callback co, and if our task to perform when finished is not null, we'll simply say tasks to perform when finished dot invoke. Oh, we need to turn this into null. Alright, so from this, what simply doing is it's checking the x value is greater than or equal to the value given and the y value is greater than or equal to the value given. Now, if you want these to be negative, just go ahead and multiply your value by -1 when passing it in, just when you're checking, but it should still work. Kind of like it's an absolute value. And we'll go ahead and save this and go back to our input test. And in here now, we can delete update. And we can actually go ahead and say using a static m underscore static input actions. And now we should be able to call this pressed input callee. So now what we'll do is every time we're performing, we'll simply say start coroutine, this guy here. And this is going to need a buttload of parameters. So let's go ahead here and give it, let's say, a private float value, and we'll say our time pressed equal to 0. And what we can do is simply pass that in. So we'll have our first off our context Then we're going to need a condition. So I'm going to say a new vector 2, and I'll just say 0.1f and 0. Then we're going to need, obviously, a callback. So I'm going to simply say null for now, but if you ever want to use coroutines to check to make sure something is, if something is still happening in that coroutine to not do something, that's how you do that. We're going to have a result here. That's going to be a lambda function. So actually I'm going to do this on the next line. It's going to go into like our own little function here. And inside of here, we're simply going to say our time pressed equals our results. Okay. We're also going to need some type of task when finished. Now, what we can do is simply create those. So under here, we can simply say input action delegate. So let's go ahead and create a private this value. We'll call it our finished input callee. We're going to need a private inputs action callback context delegate called our update input callee, like so. We'll create another function. It'll be a private void, and I'm also going to turn this into private because it no longer needs to be public. This private void function will be called rotate object. Okay. Oh, and it does need to be a callback context. So again, we are going to need a pass in a callback. So we're going to need to pass in an input action dot callback context called our context here. So we can simply go here and say our private our update input callee plus equals our rotate object. Ooh, I apologize. I just realized my mistake. This needs to be void, and this one needs to be input action callee, and I'll just give it like context. And we're simply going to pass in our context here. Apologies about that. So again, now this should work when calling it. Our finished input callee will say plus equals, and we'll assign another function called private void finished callee or finished pressing button, and we'll just call this here. Okay. So now when we are rotating our object, that code would be in here. So now we can simply pass in as a parameter our finished input callee and then our update input callee. And there you go. So that should fix that. So what we simply want to do when we're finished, let's go ahead and just debug this right here. So we'll say debug.log time pressed. And when we rotate the object, alright, so your code should look something like this. It's simply on update, we'll go ahead and rotate that object. Else, when we're move input pressed, we're simply going to set this. Alright, so that looks good. This needs to be greater than here, sorry, not equal to. A little change here. Otherwise, we'll never finish. So go ahead and click play again. You'll see now it is showing. You'll see I let go, and it shows how long we've held that input for, like so. Again, we can update our speed. Let's go a little bit faster or slower. And there you go. Nice little way to determine how long you have held your input for, which is really nice. As you can see, I'm holding it for a while. I let go, and there you go. Alright, thank you guys so much for watching. I hope this was helpful. Again, we could clean this up a little bit more, but I think that goes out of scope for the video. I know this was already kind of long and talking about delegates, talking about stuff like that, but I hope this helped a lot with invoking and cleaning up your code, so that way nothing is happening on update. So now let's recap what we learned. You now successfully have inputs in Unity. You now successfully can call inputs. You know when things are being unperformed, canceled, or unstarted. You know how to call IEnumerators, which will take in a time to determine how long you have pressed that input for, as well as invoking events when you're going ahead and wanting to check whether something's called an update or you're calling something when the task has finished, when you let go of your input. So there we go, that's how we do that. Now alternatively, if you don't want to do this while, you could check a condition here and then do your condition changing that way, and that might be a little bit better than doing it this way. For instance, you would have your own code checking being in here, and you would pass in some type, because you can't pass in a reference, but you can pass in, let's say, your class type as a parameter to the static class for your determination regarding those things. Nonetheless, thank you guys so much for watching, and I hope you guys did find this video very informative. With that said and done, I hope to see you guys in the next meeting, where we'll go ahead and most likely talk about our on trigger events. Also, if you haven't already, you should also go ahead and vote for which tutorial you'd like to see for our upcoming meetings, right? So go ahead and vote on the server. And yeah, we're definitely popping off this semester. Really exciting stuff. Currently, if we go to members, we now have 334. So yeah, thank you for everyone for being a part of the Rebel Game Devs community. And yeah, I will see you guys in the next one.